let's talk about the things that we're going to learn about today and kind of see live. So what I just did there is I used something that my brain controlled. So there's all these different concepts in here. So first, I'd like to kind of introduce what's happening in the brain that can do that, how you can visualize this kind of brain activity. And then we're going to do a little bit more interactive experiments around two things: engagement and relaxation. So there's ways that you can engage yourself that are detectable. So I can detect how engaged my brain is at any moment in time. I can also detect how relaxed it is at any moment in time. So how that works, we're going to talk about just a little bit. From there, we're going to use my brain and the technology that I have on this webinar with you all to control sounds. So you just heard that, but I'll go a little bit more deep into it. Next, I'm going to control a light. So you're going to be able to see how a light can change based on how my brain is operating. Finally, I'm going to control a prosthetic hand using different brain signals. So we're going to go through all those three things live here on this webinar. And finally, I'm going to connect a little bit to some of our student connections. So if you're joining us with the intent of learning a bit more about how this is applied in education, so we at NeuroMaker use this technology in all kinds of educational environments, from social emotional learning to STEM to robotics, all kinds of crazy stuff. So I'll spend a little bit of time talking about that, but we're going to do fun stuff with the brain. That's why we're all here. So let's go ahead and do that. All right, so let's talk a little bit about brain function first. So how all of this starts is from the brain, right? So this device is picking up certain signals and they're all emanating from the most complicated organ in our body, the brain. So I'm going to give you a crash course in about a minute and a half on how this happens. So you may have heard some of these things before, but inside of your brain, there are billions and billions of small cells called neurons that you can see right here. And between each neuron, when your brain is thinking about something, or if you are going to move your arm or anything else that requires your brain to communicate, those are happening through a place in between two cells called a synapse. And the way they communicate is by sending a very small electrical signal that, when you think of the billions and billions of neurons on top of your head, there are trillions of these little signals that happen at any moment in time. And they are actually powerful enough that you can actually detect those kind of signals from an outside sensor. So you can see this headband here. What it can do is it can detect those really, really small electronic signals, what would you like to call voltage differentials, on your scalp. So right here, like on the inside of this headband, there's these little small electrodes and they can pick up all these small electrical pieces. And the way that this works is, once again, this is a crash course. If you want to learn more, we have lots of curriculum and stuff that we can teach you through. I spend a lot of time doing that. But the crash course is, this sensor is on the front of my head on what is called the frontal lobe. This part of the brain is what regulates things like cognition. So like really thinking about something and reasoning through it. So if you're thinking hard about something, if you're relaxing, something that requires like mental energy. So if you ever were solving a complicated math problem back in high school and you're looking at your notes and you're just straining and thinking about a lot of that is frontal lobe activity. As an example of other places, so we're not going to talk through everything, but another example, your occipital lobe here. If you measure different activity coming from the back of your head, right here on the occipital lobe, that's connected to a lot of your eye activity. So if you were to close your eyes, or if you were to focus on something with your eyesight, you'd notice a lot of activity here. But as we mentioned, this frontal lobe here is where this sensor is, right? So I do have a brain, believe it or not, and that is the part that is on this part of my head. So with these sensors, we can get activity from the part of the brain that really regulates how you're thinking, like how much mental work you're putting into something. So all that electrical signal is going to be correlated with the stuff that we're going to do today. All right, so this leads us to the concept of brainwaves. I promise you this will not be a slide whipping. I just want to get some initial thoughts out there and then we'll get through it a bit more. So from brainwaves itself, if you think about it, all these electrical signals coming out, they're coming out at different, you can think of it in different strengths. So sometimes they go really high, right? You get a powerful signal. Sometimes they go really low, and they're always cycling between this. So if you are able to put a sensor on your head and you are able to look at those different activities that come in, they're always going to fall within a certain range, and they're going to keep going up and down over time. So that's really what a brainwave is. It's just how powerful electrical signals from your brain are at any chunk of time. And I'll be able to visualize that in just a second. But in case you've heard about this stuff before, there's all kinds of different waves. So there's alpha waves, there's delta waves, there's gamma waves. And those all are different signals that are coming from your brain, right? So if we're able to match how fast some of these signals come out, you can detect certain things about what you're doing. So for instance, like as you can see here, if you get a lot of alpha wave activity, you're going to be this is typically going to be correlated with how relaxed you are, or being awake, like as opposed to something like a gamma wave, which are the fastest waves. These are going to be noticeable in heightened perception. So if you're really focusing in on something that takes, like a lot of Olympic athletes will train on these kinds of signals. So this is just a long way of saying, by determining what kind of signals are coming from where in your brain, you can really learn something about your current mental state. And where all this comes from is this device. So this device, as I mentioned before, it's picking up these signals. And what I'm going to be able to do, I'm going to share this into the screen in a minute so you can see it live. You're going to be able to see these brain waves live. You're going to be able to see what happens when we, on our side, we take these waves. It's really hard to look at a piece of just one brainwave and really detect what your current state is. So we do a little bit of that processing so you can learn it from us. So we can detect really how attentive you are, how engaged, how, if you want to use this for meditation practices, how relaxed you are at any point in time. And then we can use this to run all kinds of experiments. So let me stop talking about it and actually let me show it to you. So you can see it right here. So this is what's happening inside of my brain live. So this is actually the software that I used to give you that little brain demo that you just saw. So right now you can see here, this is what I mentioned. These are these raw electrical signals that are happening in my brain right now. So these are measuring everything that's coming from these sensors. And as I mentioned before, they're measuring electricity. So for instance, if I blink my eyes, that's going to generate small muscle signals on my forehead, which are going to be triggered by electricity, which you'll be able to pick up. So let me blink a couple times and you're going to see these spikes really come up. Ready? So you can see there, so you can see some distinct eye blinks, right? So there's all kinds of signals coming up in here. Of course, nobody's going to look at this thing and say, oh, I know exactly what's happening. So that's actually where we've spent a lot of time working on this technology to kind of make it a little bit more presentable. So we've taken these raw signals and we've turned it into things that are a little bit easier to use. So for instance, I talked about alpha waves a second ago. Here are just those alpha waves. So if we took just those waves from this raw plot, just those, like you can see how strong those are at any moment in time. And using that blink example, alpha waves can also be triggered by eye blink. So if you see me blink, you'll see the alpha waves go up too. And of course, there's lots of other brain stuff that happens there as well, but you're going to see that in just a minute. So of course, we want to use this for something a little bit more useful. So you can see here, there's two plots, and I'm going to make this a little bit interactive for you all, but I'll just introduce it briefly here. So we have two specialized plots here. Let me start with the meditation one first. So we actually worked with a number of meditation experts in Boston, and we mapped the brain signals that a meditation expert would have when they're meditating. So what we've done is, the closer your brain state is to what you could call a professional at meditation, is the higher the score is going to go. So you don't need to worry about brainwaves and all that stuff. We've actually used some really complex AI and other procedures like that to make that happen. So obviously right now I'm not meditating, so you're not going to see a lot of activity here, but those are one example of something you can pull out of that information. So a second one here is what we're going to use a lot today, is what we call our attention algorithm. And what I'd like to call this is engagement. So this is going to measure, the higher this goes up, it goes from a 0 to 100. The higher it goes up is the more active and engaged that I am. So if I am thinking really hard about something, or I am doing something that takes a lot of cognitive work for myself, like we're going to go through all those concepts in just a bit, and you're going to see me use this to control other things, this score is going to go up. If conversely, my mind is really blank, I'm either daydreaming or I'm super relaxed or something you can imagine, there's not a lot of complicated brain work going on, this score is going to go down. So as you can see, I'm kind of hovering around the middle because I'm not doing something that's really relaxing nor really cognitively complex at once. So it's going to stick in that middle plot. So we're going to have some fun with this. So we want to break these concepts down a little bit more. And then we're going to use these to control all those stuff that I talked about. So I've got a whole bunch of goodies here that we're going to talk about. So we'll be able to control this robotic hand with my brain. I've got a light that I'm going to share my camera on in just a bit that we're going to use to control this. But before we do that, we want to make sure that like these concepts are crystal clear, because you'll see how the philosophy of what we do really ties into this in just a moment. So let me go ahead and move this over here. And of course, I am here to torture everybody on Earth. And the way I would like to torture you is by helping me fill in this chart. So as I mentioned before, we're going to be controlling everything today through a mixture of becoming relaxed and becoming engaged. So what I'd like to do first is for you to help me kind of fill in what activities you think would make somebody relaxed and what activities you think would get somebody engaged. So let's start with relaxation first. So I am going to start up another quick poll in just a moment. And then I'd like you to fill in what you think that could be. So I'm going to activate this. Jamie, if you wouldn't mind putting that in the chat. So this will be a relaxation poll. So what do you think will make us more relaxed? Let me present this. So here's our word cloud. All right, so we have meditation, we have exercise, breaths, puppies. Of course, puppies are making relaxed. Well, I guess it depends what kind of puppy it is, right? If it's a really annoying, loud puppy, it might not make you too relaxed. So breathing, eating, laughing. Okay, yeah. So they got deep something, breaths. So let's test that out. Let's test that out. So let me take it. I'm going to write down a couple of these. So I see meditation. I see laughing. You know what this means? I'm going to ask somebody to tell me a joke, right? All right, laughing. I can't really swim today, but I'll try that at some point. Exercise, I'm too lazy. I don't want to get up. I'm also kind of sick today. So what are you going to do? All right, so let's try some of these out. So let's start with a few of these. And like I mentioned, we'll be able to measure these with our handy dandy BCI application. So let's get that back on screen. All right, so I'm going to uncover some of the weeds here in a minute, but let's try one of these out. So let me try meditating for about 20 seconds. And what I'd like you to do is take a look at this meditation algorithm. Does this change? And this attention one. Remember, this attention algorithm is measuring how engaged I am, right? So if I'm meditating, I'm assuming it's probably going to be less engaged, and meditation will probably go up, but let's try it out. So give me about 30 seconds. I'm going to meditate and take a look at these readings and see if they change, okay? Okay, let's take another look. All right, so as you can see, it looks like meditation was a good example that was put up in the chat. So the more I meditate is the lower that attention algorithm is going to go down. So kudos to that person who mentioned meditation. As you can see, my meditation algorithm went up a little bit, but remember, this meditation algorithm is designed around people who are sitting down, meditating, getting to a very meditative trance for quite a while. So you could see it go up a little bit there, but to get it really high, you're going to have to really work for it. So that was a great example. Actually, just because we can do that, let's see if we can try something else. So if somebody, I'm going to look at the chat real quick. Could somebody please tell a funny joke? And then we'll take a look at my meditation and attention reading, and we'll see how that changes. I am not giving a lot of promises here, but just because it was brought up, we have to try it. So I'm going to keep a look at the chat and let's see what a potential joke could be. My personal attention is pretty low. So if I don't get a good joke in about 20 seconds, I'm probably going to switch to the next activity. So I'll fill in a little bit more time. All right, what did the cannibal give the other person? What did the cannibals give the other cannibal late to the dinner party? The cold shoulder. Nice. Well done, Todd. Did that change? Okay, well, attention, it's staying pretty stable. Okay, meditation. Oh my goodness, meditation went up a little bit. But I will tell you, so, okay, Hillary's got another one. I'm afraid for the calendar. Its days are numbered. All right. Well, it looks like my attention actually went up a little bit there. But yes, I'll explain a little bit the neuroscience behind that in a second, but it's always good to test things out. So not a huge change, but it's always worth testing out, right? All right, so we just did a little bit of testing there with relaxation. Let's try engagement. So once again, I'd like to put a little poll in there. Now, what do you think will get somebody engaged? So remember, meditating like that, put my score down. What do you think will make my score go up? So I'm going to activate this poll. Once again, if we could drop that in the chat. So remember, what activities can I do to make myself more engaged? So let's put this on the screen. All right, so the word cloud, we got counting, reading, math. Let me write down a couple of these. We got counting. Look at this, I'm reading right now. I wonder what my brain's doing. We got a movie, drawing, objects, book. Is book a verb? I think we can estimate that that's probably reading, right? All right, counting, driving, objects, focus, watching. Oh my goodness, like focusing on this is probably bringing up my attention. All right, so we got a lot of activities there. So let's go ahead and test out some of these, shall we? So I'm gonna, well, I imagine you're putting in more stuff, so we'll give everybody a chance to throw some in there. Concentration, playing, remembering, memories, operations, surgery. I think getting it or doing it would probably be pretty attention drawing. Let me put that on there. All right, so thank you for that. So we got a bunch of activities here. So let's test a couple of them out. And I'll walk through kind of how this is designed in a minute, but why not do something a little bit more engaging? So once again, we have our attention algorithm. So if we're measuring engagement, like I said, we're going to want to take a look at this. So remember, the closer it goes to 100 is the more engaged I am. So what I'm going to do is I'm going to read a little bit, and we're going to see if that brings my attention up. So I'm going to give you a couple of caveats afterwards, but let's just test it, right? Science is all about testing things and being wrong and all that kind of stuff. So I'm going to read a little bit. I've got some lovely reading here on real-time PCI control. If anybody wants to put themselves to sleep later tonight, I'd be happy to give you a copy of this book. So I'm going to go ahead and read it for a little bit. Please take a look at my attention, see if it changes. Once again, I'll do this for about 30 seconds. Okay, so let's take a look. Well, whoever mentioned reading and focus, that was a pretty good example, right? So, so I'll uncover some of the weeds behind that now from our neuroscience standpoint. So one of the things that we like to talk about with this kind of algorithm is that it's really measuring kind of what one can interpret as like cognitive energy. So something, if you're really expending a lot of mental work to do something, this algorithm is tailored to go up, because your brain, as I mentioned before, your brain's going to give off those special electrical signals that are going to be able to be captured, and then we can interpret that using this kind of a model. There's a lot that goes on behind the scenes. We spend a lot of time really educating people on how this works, but as you can see, you can get some reliable results for how these things work. And in this case, you know, I'm reading something a little bit dense, so this is all very technically heavy. If you were to read something that would relax you, you would also be able to see that come through on the data here. So now we have seen and of course, this takes a lot of training. So if you need to learn how to meditate and relax your brain, it's not like you're going to be able to get it perfect on the first shot. Like I've been doing this for years. So like you'll be able to learn a little bit more about your brain by doing these activities. But one of the biggest things that I'd really like to highlight here is, you know, through this kind of a system, like we're able to see how different brain activities can be represented in a way that we can all perceive them, right? So if you ever ask somebody if you're relaxed, like now you can see something a bit more objective. But what's even more interesting, in my opinion, is we can now use this to do something else. So for example, as I mentioned, we're going to use these things to control outside devices. Like you already heard those noises, right? So now we can unpack that a little bit. So what I had on that little beeping that you heard was the higher my attention went, was the higher pitch note that was played. the lower my attention went was the lower pitch note that was made. So we can use that to control sounds, and we're going to use it to control all kinds of other stuff too. So, and I realize there's a bunch of questions coming in, but I'm so in the zone now. We're just going to go through this stuff and we'll save questions for the end. So that is a quick, so now we have a little bit more understanding on how these different things work. Let's use these to do some interesting things. So let's take a look at what's queued up here, and let's actually get to control some stuff. Let me clean up my desktop a little bit so you're not looking at a bunch of crazy tabs. All right, so you just saw that live. So what can we do with this, right? So now we know that we can take attention and relaxation and we can turn those into numbers from 0 to 100, right? So what can we do with this? Well, we can collect those signals, right? We can interpret them. So we already did these two parts, right? So we know that the brain's giving off these signals. We know that we can interpret these things in a meditation and attention algorithm like you just saw. Now we can output commands. So for instance, if we have our attention set at a high level, we can say, hey, when your attention's really high, make this color on a light, right? Or conversely, if you're relaxed, let's make a more relaxing color from a light. And I'm going to show you how to do that live, right? We can also control a motor, right? So if you are really attentive, maybe you can make a fan spin faster, or you make it slow down. You can control sounds like you already saw. Another thing, and all these things I'm talking about are activities that you're going to see today, but you can imagine with all the different kinds of technology improvements that are happening now, people are using this around the world to give, paralyzed people a way to control a prosthetic arm. That's actually one thing that are similar to what another division of our company does. You can do things to help people relax and meditate better, right? So another part of our company does that. And we just get to have fun. So here at NeuroMaker, we get to use this stuff to learn a lot and then to really make something interesting. And this can get even more interesting too. And of course, I got to get this out of my system before I show you the live examples, because this stuff's really fun. But you can imagine the kinds of systems you can create. So for instance, if you create a light system that gives you relaxing lights when you get too nervous or attentive on something, you can actually use that to calm yourself down. So to keep yourself in a perpetually calm state, right? Of course, this takes a lot of testing and refinement, but these are all the kind of things that people can create. Scientists are out there making it now. And really what we try to do here at NeuroMaker is to inspire younger students to do that too. So this is just a little bit of ideation here. You can see this. So let's go ahead and actually control something. All right, so I'm gonna have to set up a few things on my desktop. I'm actually gonna turn off my lights here. I have right on my left, I have a separate camera on a gooseneck that's gonna show you a light that I have hooked up to my computer. And we're gonna be able to control the color of that light using my brain signals. So I'm gonna go ahead and put my dashboard back up on the screen here, right? So we saw this, right? So you can see here, these different numbers are operating in real time. And what I can do is I can use this 0 to 100 and use that to control different colors of a light. So what I'm about to show you, and while I get this ready, I'm gonna fill some time, is every time this attention, I'm gonna turn off, well, let me switch cameras actually real quick. All right, there we go. So now you can see the light here. I'm gonna turn things off to make it a little bit easier, but that big white circle, or sphere, I guess, if we're gonna get really technical, is going to have a light inside of it, and that's gonna change colors depending on how relaxed I get. Set some things up here. You're going to hear all kinds of weird stuff happening in my room. All right, I'm going to turn this on in give me about 20 seconds to set this up. I'm going to use this same device. All right, I'm going to reset a couple things. And what you'll see is every increment of 10 that I change. So every time my attention score changes by 10, it's going to create a different color. So let's go ahead and get this set up. So I have this actually set up, but for any of fellow nerds out there, I have this set up to an Arduino controller, which is located right there. I don't know if you can see it with the lack of light right now, but you will see it when I turn it on. And it is going to turn on. So let me replace the code that I have in there now. All right, so here we go. So I'm going to connect my headband. And now you can see on this button here, this is going to relay my brain signals to that device. Let me switch up a couple of things. It's a live demo, so of course, you're going to have to do more than you expected. Connect this thing real quick. And then we're going to see some lights change. All right, so here we are. So now you can see by hitting this button here, this sends this data. So this attention data that I have here is going to be output to this control. You see those red lights. There's a little Arduino R3 controller. So every time my attention level changes by 10 points, you're going to see a different color. So I have it set up for a bunch of different colors. We have royal blue, we have purple, we have magenta. So let me just start to meditate, and you're going to see these lights start to change. Once again, give me about 30 seconds. Okay, so we can see lights change a little bit there. So I have it here just to cycle through a bunch of different colors, but just to show you how this stuff works. But one of the experiments that we love to run here is, to create a certain color when you're really relaxed or when you're really attentive. So you can have this switched up to whatever combination of these attention scores that you want. And we run a lot of experiments here to do other stuff too, but that's a quick intro to what that looks like. So now we've seen a light. Let's see what else we can do. So let me move this over to the side. So, all right, we can check this off. We control the light. Let's control a prosthetic. Oh my goodness, prosthetic. So let me go ahead and change my camera. So there'll be a little bit of fiddling around here. You also probably want to see me in the light. I don't want to look like a gross zombie. Let's get these lights back on, shall we? All right, so now what I have next to us, this is the NeuroMaker hand. Yes, this is a slight Billy Mays product plug, but what are you going to do? So we have here, this is actually the prototype that we use to create an actual prosthetic. So you'll see here, we got a control box on the inside. We have 5 servo motors on the back, which are going to pull on tendon wires that will create different gestures. So what I'm going to do is I'm going to take that same signal, right? So once again, we're using those same attention 0 to 100 metrics, and we're going to use this to control different gestures, okay? So I'm going to set things up a little bit here. I'll let you see it live just so you know that I am not pulling your leg. So I am going to restart this, and then I'm going to put the appropriate code inside of the controller here. So inside of this hand, we've got another control board, and I'm going to use that to take the signals that are coming from my headband and use that to command different motors inside of my hand. So it's going to take a little bit of time to make sure this ends up on camera right, and we have all the right code logged in there. So give me just a moment. And what I have this set up to do is I have 3 gestures. So there's going to be a peace sign, right, which we can call scissors if you want. We have an open palm, which we'll call paper, and we have a rock, which we'll call a fist. So when my attention score is very high, I'm going to make a rock, right, because we're really stressed, we're really focusing in on something. When we are really relaxed, I'm going to create a peace sign. And when I am in between, I'm going to create an open palm. So let me upload the code into this hand. All right, we are looking good. I'm going to connect my headband here, and we're going to see this move live. So once again, this is just the way that we have these things set up, but you can set these up in all kinds of different ways too. So we've had other projects in the past where people could focus in to grab certain things if they wanted to. We actually use this on the prosthetic side of our business to control other things like taking muscle signals and then being able to use those to help an amputee control their prosthetic arm. But today we're going to use brain signals to control those different gestures. So we got this set up here. Once again, we're going to use this attention algorithm, and I'm going to walk you through what this looks like when we send signals to our hand. Let's go ahead and do that. All right. So you can see here, I have it set up that when my attention score is between I believe it's a 45 and a 100, it's going to create a fist. Now, what you'll see is when I start to relax, I'm going to start meditating again in a few moments. When this goes between a 50 and a 35, it's going to create an open palm. When it goes from a 35 and lower, it's going to create a peace sign. So let's go ahead and watch that. All right. So you can see there, I've spent a lot of time practicing, so I can meditate pretty quickly. And then, of course, as I start to get more attentive, these signals are going to go through again. I tend to focus in really well when I explain things. So you're going to see my attention score start to rise. And you can see there. So you can set this up for all kinds of different gestures and all kinds of different inputs. And one of the things that I like to emphasize with this stuff is like really think about what else you can do. Like you can control this to anything else that you can program and control. So any other kind of lights. I am a very interesting man, which I will admit. I've controlled lasers that I used to annoy my cat, because why wouldn't you? Controlled to their headband. You can do all kinds of stuff on a more kind of fun side, but we can use this for really powerful ways to help, particularly other aspects of assistive technology as well. So I hope this gives you a quick example of a few things that you can do with your brain. Let me go ahead and turn this off and put it to the side so we don't have a hand in front of me screaming. So we just controlled a prosthetic. So just to walk through a couple of examples that I talked about, especially from the education side of things, huge kudos if you're out there listening to this. We actually had a group of students at River Hill High School in Maryland use this to create their own attention feedback device while you're driving. So they use this to create a little light, which is just out of focus here, that would come on when a driver gets distracted. So you can use this for those kind of neurofeedback systems. This is actually being used in, I think, Citroen, GM, a few other big car companies are using this kind of technology and testing it. So we can use from an educational point of view. So you saw here what you can use to control a prosthetic. And just a few extra words on education itself, and I'll open it up for some questions and some other prompts that we can talk through. But the way that we like to really encapsulate this within NeuroMaker is by using this technology to do kind of three big things. So the first one is really, as you can see here, with all of those different brainwave signals that I had up on screen, the first thing that we use for this is to really understand and kind of control your own self, right? So you can really understand how to relax yourself, how to make yourself more engaged. And especially for a lot of people in middle school and high school, these are really obscure concepts. So giving people something to have feedback on this, and then also to do something interesting and fun with it, is a great way to kind of create a better control vector for their own social emotional learning. So that's a big part. And the cool thing is we get to actually combine this with technology and learning. So great, like now you can control your brain to become relaxed or attentive on command. Let's use that to control something, right? So let's build a circuit. Let's create something that you can control with your mind, and like really see where that goes. So like, and we have different ways where you can put this together with Python or C++, like Arduino Unos, or like other kinds of things that you can use if you're a STEM enthusiast. So there's ways that we could use it there. And then finally, as I mentioned before, we like to use this as a platform to create and build. So the thing that makes me personally the happiest is to see people create their own projects and really take on a problem for themselves. So as I mentioned, we had a group of students that did this kind of a neurofeedback device for a vehicle. Believe it or not, this is actually a lot more approachable than it sounds. And I hope, if you want to take a closer look at our curriculum or learn with us a little bit more, you'll be able to see how we unpack this and guide people through it. And you can see here, we've actually done a lot of seminars in the past. This one was right out of Boston. We had a bunch of high school students come in and do projects with us. So there's all kinds of fun things you can do. Hopefully we can create a platform where people really want to create and build. And then one last quick note on our curriculum. So as I mentioned, we go through all these things step by step, and this is just for BCI itself. We have a whole huge curriculum for the hand as well. So going through biomedical engineering and everything else that goes along with that, programming and AI, but particularly since we're talking about BCI today, we like to have people go through everything. So understand the world around them with this, how this connects with their CTE pathways, what kinds of different biology and neuroscience concepts we can add in there, how you can control the world around you, like I showed you with those lights and sounds and other things like that, how to understand yourself. So what kind of experiments can you use to become more focused or more relaxed, the impacts and the ethics of this technology. A lot of what we're using here today is based on learning about relaxation and engagement. But there's all kinds of interesting stuff you can do with this, and we want to make sure that people understand the implications of that well. And then finally, my personal favorite is design thinking. So taking it somewhere and making it something amazing, making it your own. So our curriculum supports that. We'd be happy to walk through it if that's something you're interested in, but got to throw it out there. All right, so you have listened to me and seen my brain work for about 40 minutes now. If you do want to learn more about us, we have all of these different resources that you can connect with. So we have a YouTube channel, Instagram, Twitter, LinkedIn, the whole 9 yards. So feel free to engage with us. We're going to spend the rest of our time on Q&A if anybody else is interested in asking questions, and we have some prompts that we can ask through. I'm looking at the chat log and look like I have a mountain of questions to get through. So I'll do the best I can. But with that, I left a couple questions up here to discuss if there's nothing else to ask questions about. But from here, Jamie, I don't know if you can kind of see what's happening out there in the crowd, if there's any questions, or we can jump into this. So I'll throw it back at you.
Yeah, Andrew, thank you so much. These demonstrations were really great visual representations of how the BCI technology can really engage the world around us. There are some questions that came in from the chat, so we're going to go ahead and tackle those before our time is up. If you would like, there are some great discussion questions that Andrew has on the screen. If you'd like to share your responses in the chat, that would be wonderful. But let's dive into the Q&A because we do have several questions. So the first question that we have is, can you explain a little bit more about how the BCI sensors work?
Yes, so I will give you the fastest introduction in the world. There's a whole lot to unpack, but the short answer is, so I'm going to take this off now since the demos are more or less wrapped up. I can do more if people are interested, but you can see here on the inside, there's 3 different metal sensors, right? And this is made up of a special conductive material. And as I mentioned before, everything that's happening in the brain, or at least that we're measuring, there's all kinds of interesting ways to measure brain stuff. I'm going to try as hard as I can to stay focused on this question because there's so many interesting things that we can talk about. There's other systems that they actually measure, like you can use special lights to look at blood flow in different areas of your brain to kind of find out what kind of activity is going on. We don't do that. What we work for is, or what we work with are electric sensors. So honestly, if you want the easiest answer in the world, of course, this kind of cheapens the whole process, so it makes a good rhetorical device, is it's like a battery tester, right? So we've all put, back in the day, if you had some AAA batteries and you wanted to see how much voltage was left, you'd put that inside of a little sensor, right? So you could put like 2 wires next to it and you get a voltage output. So if it's a 5-volt battery, maybe there's 4 volts left or something like that. This is essentially a much more complicated process of using that. So this is going to, what it does, and I could talk all day about this, and there's more curriculum to support it, is it measures the difference in voltage between different points, and we do a bunch of calculations to find out how strong that signal is, and then we map it over time and over frequency domain. I'm leaving a lot unexplained there, but essentially these are electric sensors. We take that electric activity and we run a bunch of algorithms over it to process out a bunch of stuff that we don't want and keep stuff that we do want, and then display it in those different forms that you saw on the screen just now. So I hope that answers your question. There's a whole lot more to unpack there, but that's, I think, the fastest kind of explanation I can do right now.
Thank you, Andrew. The next question we have is, would the brain have the same level of attention activity while watching a movie? So you had done the demonstration with the that measured your attention waves. So what would that look like if somebody were, say, just relaxing and watching a movie?
Yeah, so of course these are metal sensors, right? This headband can't look outside the world and see what you're doing. This thing is set up, so the hardware, the software, all that visualization that you saw is set up to do those 2 things that we talked about. Measure engagement, right? And we talked about that a lot today, which is how hard, for lack of a more scientific term, like how hard does it take you to really think about doing something? So if you are watching, so to use the movie example, if you are having to really process what's coming in and you're totally focused in on paying attention to it and understanding what it's doing, you should see your attention algorithm go up, right? So you should go closer to 100. Conversely, if you're really relaxed while you're watching it, or you zone out, or there's less mental activity going on in your brain, that'll come down. So it's hard to say, and it really depends on how people react to it. So if 2 people are watching the same movie, they might have a different response. So some people might be relaxed. I typically get really stressed out when my girlfriend puts on something that I don't want to watch. So that might lead to a different brain signal than if she's really engaged or relaxed with it. But that's actually some of the fun projects that we run with students and other people that use our technology is, how does your brain operate while you're doing something? like no two people are going to get the exact same thing. But what you will get is a good look at what your brain itself, how your brain is responding to that. So I hope that answers your question.
Yeah, that makes a lot of sense. Thanks, Andrew. The next question, what grade levels are best suited for these resources? So we've seen today the BCI headband and we've seen the prosthetic hand. So what are the ideal grade levels for these resources?
Yeah, so there's all kinds of different ways that you can use this. I've personally seen students as young as 5th grade all the way through high school use this in some form or another. And you can imagine you can have people learning about how to become more attentive or relaxed. That does not involve any programming. That does not involve any fancy neuroscience. It's really using a dashboard like this or something similar to it and kind of figuring out how you engage with something, just to give yourself a little bit of mental clarity about how this works. So our curriculum resources are designed for different age levels. So we have things, this is one of the things that we walk through a lot in our implementation and a lot of our training, where we'll kind of diagnose the pieces of our curriculum that are most suited for different audiences. But typically from 6th grade to 12th grade, like we have resources that are appropriate for those different levels. And we're always working on more stuff too. So stay tuned if there's other ages that you're seeking to work with.
And I just have to add, I had the pleasure of working with a district in Montana, and they had amazing success with their 4th and 5th grade STEM students in a robotics program. So, yeah, it's all about adaptability and adjusting, and they really have some great success coming out of there. Okay, next question. How can one know if the neuro data generated by the nervous system is conscious or unconscious? Do the sensors know how to distinguish the two? And I think I know how you're going to answer this question, but let's go ahead and see what you have to say.
Yeah, so once again, there's all kinds of different, I'm trying to process how much I want to share here, but depending on the kind of signals that are coming from your brain, like you're going to be able to see that in different ways. And a lot of the differences between being conscious and unconscious are going to be those different brain waves that we talked about. So typically when you're unconscious, you're going to be giving off brain waves that are a lot lower frequency. So like slower waves, typically those are associated with really like deep thinking or things that you kind of intuitively do. So you imagine a lot of the brain signals that are coming out to, control your digestion system and your eyesight. Like you don't have to actively think about those things. Those are like involuntary things that your brain will regulate yourself. So you can, one quick answer to that question, I know I have it on screen and I disconnected my headband, so it's not going to come through right now. But one of the things that this headband is set up to do is to measure those electrical activities coming from this part of the brain. And like on this raw EEG plot that we saw earlier, that's going to give you the waves. So by using some fancy math over that, called a Fourier transformation, you'll be able to kind of see what these different waves are at any point in time. But the way that we have this system set up, if you go to a hospital, you'll see, like you might have saw before, there's different skull caps with like 1 million, like up to 40 or more different sensors on top of your brain. Those are going to be tailored towards very specific, minute brain signals. So those will give you the kind of resolution you're looking for to do things that are a bit more medically complex. But to give you a quick answer, this headband, the software is set up to really work with engagement and relaxation. If you have like a crazy hospital device that can like hone into more of like all those different signals coming out, you can do more complex things with consciousness and unconsciousness. But the short answer is you should see different brainwave patterns from parts of the brain depending on whether you're conscious or unconscious. So I hope that helps. I know there's a lot in there.
Thank you. Okay, and then the next question refers to the projects that students can complete. So you alluded to the one project where the students created the distracted driving device. Mm-hmm. So do all students who utilize these resources get to participate in those projects in our capstone project, our NeuroMaker challenge? Can you just share a little bit more about that?
Yeah, of course. So I'll even queue up a page on our website and throw it in here in just a moment. But the short answer is yes. Like so long as you have one of these devices, you can sign up and create your own project and submit it to us via video. We have our own panel that reviews them, and we do it twice a year. So so we collect submissions on December 20th and the last day of June. So this is coming up. So long as you submit things before that window, it'll take us about 1 month to review everything, and then we'll do a webinar and give out prizes. So you can see a little bit more on that here, and we do that for all of our different pieces of hardware. So the hand that you saw, that so this device, we have students that create their own projects for that. We have students that create it just for BCI. We have some that do both. If you take a look at our website, neuromakerstem.com/neuromaker challenge, if you look under products and see the challenge there, you can sign up for this and do it for free. We'll review it, and like we actually give out cash prizes. So we have a high school and a middle school range. So the first, second, and third prize in each different category will get one of these cash prizes. So we give out everything from $1,500 to $500, thanks to Brainco, which supports us. And you can see some of the projects that came in the past. So you can see here we have the neurofeedback device that high school students in Maryland created. We have other projects that came from California and Indiana, Massachusetts, South Carolina. And there's a bunch on here that are in our social media. We haven't put up on the webpage just yet. So it's free for anybody who has the materials.
And I went ahead and put that link in the chat as well, so everyone could take a look at the NeuroMaker Challenge page. Just 2 more questions. Can you expand on how we suggest this being used in schools? And I know there's a million ways that this can be used in schools, but I think maybe they're just looking for just a couple of ideas for how to integrate this kind of technology into their programs.
So by this point, like we've been doing this for quite a few years now. There's not much that we haven't seen yet, but I'll give you some examples. So on the lower end of things, like we've had people start this off with STEM nights or include it in their makerspace where people can kind of creatively use it in whatever form they see fit, a more less disciplined environment, or that's probably the wrong word, but a less structured environment where people can create their own projects and learn on their own. Actually, some of our coolest stuff has come through those kind of things. Going up another step, we've seen people use this as a module within another class. So if there's a robotics class and they want to introduce BCI technology into it, like you have a robot and you learn how to code it and do whatever, and like now you want to control it with your brain and learn all the different neuroscience and neurofeedback pieces that are inside of that whole learning how to control your brain piece I was talking about. So becoming more relaxed or becoming more engaged. There's a lot of really cool social emotional stuff that you can add into a STEM environment like that. But like I mentioned, starting off as some kind of a session within a robotics class, a computer science, programming, biomedical engineering, and all the pathways that filter into that. We've seen this in other interesting CTE classes as well. People testing stuff out with marketing ideas, like you can get brain activity and test out how people engage with it. It's been all over the place, and like going up another level. So our curriculum, if people like really want to follow along our curriculum, like we've provided resources that people could fill up an entire, AI pathways class or a programming class, whether it be block-based or C++ or whatever. We have learning resources that can schedule around a middle school or a high school, age appropriate semester or year. And then I think the highest level that we really love to see too is there's actually many schools out there in the US that offer a class that really focuses in just on these concepts. So they'll spend a year, whether it be an elective or something else, they'll actually build out an entire learning progression around using these kinds of technology. So schools that work with us there, we have professional development that supports that. We have like these capstone projects that people can use as certification. There's all kinds of different ways. So schools that have built this out into a multi-year, like a class-heavy progression, like really built it into the school curriculum, or that people kind of start off with different experiments. There's a whole wide range that you can use this in.
Excellent. Those are great suggestions and great ideas. Thank you. Our last question, and this might be better suited for our sister company, but the question is, can this, in an advanced manner, be used to perform pain management or to improve chronic pain therapy? Is this the future, maybe? So if you want to speak a little bit to that.
I think you answered part of the question right there. I'll talk just a teeny bit about this, but I think you'd be best served by, like, as you mentioned, we have another one of our key brands, so Focus Calm, like they are into like the wellness space and kind of using this in a like a level like that. It's actually the exact same hardware. So you can use it for all kinds of other applications too. But the short answer is yes. Like there are, like I mentioned, this is part of the whole discipline of neurofeedback, which is a fancy way of saying, being able to display how your brain is reacting to a certain thing, and then being able to make mental changes so that you can adjust your feeling or kind of mental activity based on that. So for instance, if I can measure how my reactions are when something hurts and I need to distract myself from it, or you need to find a way to relax, you can see how well you are doing that by visualizing this kind of information. Of course, we're not trying to do a lot of pain therapy in STEM classrooms, at least I hope not. I don't think they're that painful, but hopefully not many other people think otherwise. But if you want to learn more, I'd recommend that you get in touch with the Focus Calm team. They have amazing research scientists, and I think a little bit more medical information that they could share with you.
Andrew, I have to agree with you. I actually work with a school district who is using Focus Calm for their workplace wellness initiative with their entire staff. It's one school and the entire staff is participating. And the headmaster of the school said that she had some pretty chronic neck and pain issues, and so she's been piloting Focus Calm before the staff members do. And she sent an email just last week saying how she doesn't know if it's correlated, and she can't talk to the science behind it, but she has a reduction in pain, which is really impressive with using some of the resources that she's been using with Focus Calm. So I would say definitely part of the future. And I did put my email address in the chat for those of you who have additional questions or would like more information on Focus Calm or NeuroMaker or the BCI device or the prosthetic hand or anything else that we've talked about today. So with that, Andrew, I'm going to thank you so much for your time this afternoon. I know that we're right at our hour, and I want to thank everyone else for joining us on this webinar. I hope that you learned a lot and got to see some really interesting things. And as promised, you'll be receiving a donation for the booster program of your choice via email in the next week. So please feel free to reach out and have a great rest of your day.
Thanks, everyone. And as Jamie, we'll have a recording of this too in case people need it for other purposes. We'll get that up on our YouTube channel as fast as we can. And just to echo what Jamie said, thanks again for joining us. It's always really fun to show off this stuff and kind of see what other people can do with it. I'd be really happy to see what things that we could do to assist you in whatever you'd like to do with this. So I'll leave it there and wish you all a great day. Bye-bye now.